day viewers, you are welcome to my YouTube channel, Maths with Adevic. I'm Victor Adewale Adeleke. Here our major focus is to teach you mathematics from the basic even up to advanced. If you are yet to subscribe to my YouTube channel, do well to subscribe, like and share. It's very important so that when I post materials like this, you will always get notified. Now if you have been following my class, in my previous class, the last class on Laws of Logarithm and Indices, I gave this question, the last class part 4. I gave this question 3 to the power of x plus x equals to 5. This, as I explained, is a very kind of exceptional question that we are going to try to puzzle out today. Now, this question, the reason why this is an exceptional question that I explained is because you have 2 to the x. The unknown is a power here, and the unknown is also a base. So because of that, this kind of question needs a thorough application of math rules. Because if you try to use your normal algebra, which you already are familiar with, you have problems. But we are going to be using the Lambert function today to solve that question. And Lambert function is what? The symbol is W. X to the power, x exponenting x will produce x. This is the law of the Lambert. Whenever you have x, a number, for example, 5 exponent of 5, and you are taking Lambert of it comes out as 5. This is one simplification that was done by Lambert many years ago. So that's the system we're going to use that we're going to apply here now to puzzle out and bring out the solution to this question. Now let's go. Now what you must understand is that normal, you must try to isolate the value of what you are looking for. So we are going to move x to the other direction. Doing that, you have 2 to the power of x is equals to 5 minus x. Once you've done that, divide both sides by 2 raised to the power of x. Now, this is the same thing. According to the law of mathematics, it becomes what? It becomes 1. So you have 1 is equal to that. So what do we have here? According to the law of indices, because we have this at the base, 1 over x raised to the power of a must be equals to, can also be equals to x minus x to the power of minus a. You can write that. So that's what this is now. Because if you want this, it's the same thing as 5 minus x 1 over 2 to the power of x. This is what it means. So instead of writing like this, you can simplify and say what? Minus x. Now once you've done this, now the next thing to do is to multiply both sides by 2 to the power of 5. Why are we trying to do that? Because we are trying to make sure that this looks like a Lambert function. We are going to multiply both sides with 2 to the power of 5. Do not forget the golden law of mathematics. Whatever happens to the right hand side happens to the left hand side. So when you multiply 2 to the power of 5 to both sides, we have this 5 minus x 2 minus x times 2 to the power of 5. Don't forget you multiply both sides. Now according to the law of indices, x to the power of a times x to the power of b will become x to the power of a plus b. This is the rule of indices. If you are not familiar with this that I'm doing, go back to my class that I've taken, Laws of Indices and Logarithms, and you will find all these laws all proven there. Now what you do, you can see that we have a plus b. The powers having the same base, and that's what we are having here. So what do we have? We are going to have that 2 to the power of 5 will become 5 minus x. When these two multiply each other, we have 2 to the power of minus x plus 5. And don't forget this minus 3 plus 2 is something as 5. It's something as minus. It's something as 2 minus 3. So minus 3 plus 2 is something as 2 minus 3. So minus 5 plus 6 is something as 6 minus 5. So that's what we are going to do here now. So we can rewrite this number, which is minus x plus 5, to be 5 minus x. Now if you observe carefully, now, what we are having, we have the base, we have the power, but we are having 2. And we cannot apply any method here. What you need to understand is the Lambert function. How are we going to apply the Lambert function? This is where the problem comes. But one thing you must understand, I think if you go back to my previous class that I gave, titled Relationship between Logarithm and Natural Logs. If you go back to that, you'll find that I gave a theorem. I proved that a theorem that exponent of lane x is equals to x. So if you punch this in your calculator, e, which is the exponent lane of 5, you get 5. E lane 6, you get 6, like that, and so on and so forth. So this is the kind of question that we are having now. Now we want to try to make sure that these two becomes exponent, because that's the only way Lambert function can be applied. Without allowing an exponent to be there, if you apply the Lambert function, that is total error. So it has to be an exponent there. So what are we going to do? We are going to mathematically manipulate this to look like the Lambert function. So we can rewrite this number, like I said, 2 can be rewritten as e ln 2. 5 can be rewritten as e ln 5. So that's what we are going to do here now. We are going to rewrite 2 to the power of 5 minus x. It becomes 5 minus x. Now let's rewrite this. You have your exponent, your ln, don't forget it's a ln, then 2 to the what? 5 minus x. Like I explained also, the rule of ln, which is the natural log, is the same as the rule of logarithms. I explained it in that class, the relationship between natural log and logarithms. The relationship is just so clear. The only difference between logarithm and natural log is that when you have ln x, logarithm has it as log x, but to the base of e. That's the only difference. So the only difference between ln and log is that log in place of ln has a base of e. That's just the only difference. So the same rule of logarithm will be applied here. What happens to this 5 to the power of minus x? It is inverted. I explained it in my second class, part 2 of laws of indices and logarithms. So what happens? This number is inverted in the back. We have what's 2 to the 5? We have 32. That's 2 in 5 places. So we have this 5 minus x. Then this 5 minus x is inverted. So we have exponent of what? 5 minus x ln of 2. This is what it becomes. Now if you watch properly, you find out that we have 5 minus x ln 2. We have 5 minus x, but there's no ln 2. So what are we going to do now? We have to apply the what? We have to make sure that we multiply both sides by what? By ln 2. So that ln 2 will affect the base here and affect this one. And when ln 2 affect the base here, the power here becomes the same with the base. And that is the only exception or the only way we can apply the Lambert function. And that's what we're about to do now. Now let's really apply that. So when we do that, multiplying both sides with what? With ln 2. So we have ln 2 affect this 32. So it becomes 32 ln 2 is equals to what? 5 minus x ln 2 exponent, don't forget is there, towards to the 5 minus x also ln 2. Now you can see that this now agrees with the Lambert function operation. You can see x to the exponent to the power of x. That's how it works. So we now have 5 minus x ln 2 exponent to the what? 5 minus x ln 2. So we can now apply the Lambert function to both sides, because that's the good rule of mathematics. What happens to the right hand side happens to the left hand side. So we have w, which is the symbol for Lambert function, 32 ln 2 equals to what? W again. Then we have 5 minus x ln 2 exponent of 5 minus x ln 2. Now this is it. Now once you apply the Lambert function to this part, it is simplified to become what? To become just the base or the power. You can pick anyone, it becomes like that. So what do we have? So we have that Lambert function of 32 ln 2 becomes what? Everything simplified, just the power 5 minus x ln 2. Now once you've had this, you can see now we finally simplified everything here. Now what do? You divide both sides of this by ln 2. So we are trying to isolate for the value of x. So you divide both sides by ln 2, divide here by ln 2. Now we can see the Lambert function now. So ln 2 cancels out ln 2. We have 5 minus x. Minus x. So once you add that, everything here, you write it. Lambert function of 32 lane 2 over lane 2. Now what are we trying to do now? We want to get 5. So if you invert everything, you finally have that x is equals to 5 minus, if you want to do, just bring this one here, becomes minus, your 5 has been here, remains there. So we have minus the Lambert function of 32 lane 2. There you have lane 2. Now when this is where the problem comes to finding the solution for Lambert. Now, like I said, Lambert's function is a function, just like we have trigonometrical functions, hyperbolic functions, and logarithmic functions, several kind of functions. So we have also Lambert function. Now, if you check your normal calculator, you have the Castle calculator and all that. You have only cos and hyperbolic functions, trigonometrical functions there, which is cos, sine, and all that. But you will never find a Lambert function. So you can use an app that I always use. You have Wolfram Alpha computational engine. Wolfram Alpha computational engine. If you open this Wolfram Alpha computational engine, you will see the sites. All you need to do is click on the search engine, this question. But if you want to click on it, make sure you write Lambert first, W, then you can write everything here, 32 lane 2, you slash it divided by lane 2. When you do this, you will have a number 2 point something. When you subtract it from, I think 2 points something above, apart from 2 point something other than 5. If you subtract it from 5, you're finally going to come out with an answer 1.71562. Yeah, this is the answer you're going to come out with at last for the value of x. And if you substitute this into this value, 2 to the power of that number plus x to the power of this number, you're going to get accurately 5.0000, which tells that you are absolutely correct. This is the question demystified that I gave in that last class of indices and logarithms laws part 4, which is the final. And it's very simple. You can see all about understanding the function and its operation. I will draw this question with you. I will draw this question. Still like this, we have 2 to the power of x plus x equals to what? To 20. Try this one, the same thing that I have done. Just try it and see what you will come out with. If you are yet to subscribe to my YouTube channel, do well to subscribe, like and share. It is very important so that when I post materials like this, you will surely and certainly get notified. Stay tuned.